All right, so let's get started with the fun stuff. So we are here tonight. My name is Mark Schmidt, and I'm joined by my colleague, Kara Reen, and we are just going to go through some ideas, some concepts that we hope that you'll be able to use within the next couple of days or this month, right? So we're going to start with a quick quote. Simply putting technology in front of students isn't going to engage them in your lesson. Well, we really chose this because that's our goal tonight. That's on our agenda. We want to make sure that, yep, we've given you a free code or a free trial, but we want to help you so that you can use these tools tomorrow, next week, and really familiarize yourself with them and see the strength and the power in these tools. So I'll take a quick look at our agenda. So first of all, we have created a Google folder, and I'm going to switch here. In that Google folder, there's some resources there for you. There is every share code that we're going to share with you tonight is on a document in here called Brainingcamp Fall into Math Teaching Tips. We've got some tutorial pieces on how to create share codes, how to add students, and about our Brainingcamp tasks as well. So we put some resources in there for you because, like we said, we want you to be able to walk away and use our materials right away. So we're going to be taking a look at, well, Kara's going to be taking a look at some addition strategies for K2. And she's going to be working with the Rec and Rec, really a cool tool, in my opinion. I think you'll see when Kara, she's really an expert with the Rec and Rec. We'll do some work with the two-color counters. Notice I'm really putting a lot of pressure on Kara, but that's all right. She'll meet the expectations, I'm sure. She's going to do some work with some two-color counters, and then we'll do some work with our number line application. And then we'll also we'll kind of switch gears a little bit and go to I'm going to say grades 4 through 7 if you're here in the States. We'll take a look at some multiplication division patterns using a manipulative called place value disks. Some folks might call them place value chips. I think I'm discovering how to use them more and more. And then we'll take a look, coming back to the number line, on integer addition and subtraction. So I am going to stop sharing, and I am going to let Kara take over here.
Thank you, Mark.
You're welcome.
Okay, I'm going to share my screen. Can everybody see my screen okay? All right, we are going to kind of just jump in and get started. If you haven't used Brainingcamp before, you'll see that a lot of the manipulatives work in some of the same ways. And so I'm kind of not going to spend a whole lot of time on how to use the manipulatives, but kind of watch as I click on them, and you'll get to see kind of the way they all work and the way they all go. So we know that kind of around this time, you might be working, especially some of the younger grade levels, on addition strategies. And I was able to attend NCTM recently, and I got to watch Jennifer Bay Williams talk about fluency with math and getting our kids to know their facts and addition strategies and things like that. And she reminded me of the importance of Make 10 and the Think Addition strategy. And so I'm kind of going to focus on those two things because Make 10 is so important. Our whole number system is based on the 10 system and how it works. And we really want to kind of just make sure that our kids are able to decompose numbers and then get them ready for those Make 10 strategies, because that's really going to be what is a really strong foundation for the later addition and multiplication strategies and things like that. So when you are here in Brainingcamp, you will see that we have 17 manipulatives. And the first one that I'm going to kind of focus on today is the Rec and Rec. When you click on Rec and Rec, you'll see that we have the big white space, and then we have our toolkit on the side. And this is where you can drag your manipulatives from. when I drag it out, what I kind of want you just to kind of, for just a moment, is to notice about the Rec and Rec. And if you're not familiar with this tool, the beads always are going to begin on the right side. So that's our starting position is not here. And that's often hard for us as teachers to kind of grasp sometimes, but we definitely want our position, our starting position to be on the right-hand side. Because when we read and when we ask kids to look at this, we are asking them to look left to right. So here we can see that we have two shown. You can see that it's kind of highlighting blue. This means I can do something with it. I can copy it. I can delete it, just to kind of give you an idea. You can also turn on your group labels. So before I go into really making 10, this is a super valuable tool, right, for benchmarks of 5 and 10. So before we start with 10, we really want to make sure they understand the benchmarks of 5. So we want them to be able to go from counting 1, 2, 3, 4, 5. We want to get them away from that, but say, show me 5, and then they quickly grab 5 and slide over. That's a really cool prerequisite that'll help you know where your students are at as far as what they can do and are able to show. So we know there's a kinder strategy. It says for any number from 1 to 9, find the number that makes 10 when added to the given number. So we kind of we're focusing on that making 10. It's a standard, right? That in Common Core that there is there, but it's also in almost every other probably standard as well. So if I have 5, what else can I do to make 10? Now, if I grab this and just move it away just a little bit, that's where those labels are going to get to come on. And you're going to get to see that 5 and 5 make 10. I could show that 1 and 9 make 10, 2 and 8 make 10, 3 and 7. And so you're kind of just showing this to your students. You're getting them familiar with the Rec and Rec. And so you're kind of just beginning this way. I recently got to watch a really good video of this woman giving her class a way to show the Rec and Rec. So the label, I'm so glad you said that, Tammy. The label is new to me. So in Brainingcamp, if you look down here in this little settings menu, you'll see that those settings are based on what you can do with that particular one. So I'm glad you said that. The labels, we can turn them off and on. It's really for our kids that maybe aren't just quite ready yet, or they need that a little additional support to see the quantity above. So I'm glad you mentioned that you were able to kind of see that. But I was watching this really cool video, and she does this double-decker bus, and she gives the kids some context. Now I'm going to enter a share code here. A share code is a way to save our work. So I've created this task and I pressed share, and now I have a share code. I enter that share code again here on the home page in the box that says share code. So if you are not familiar with share codes, this is where you will always enter them. And then here I have, there were 10 people on the double-decker bus. How many ways could the people have sat on the bus? And this is where you get to kind of hear, and then you let your students explore this, right? You let your kids kind of talk with you. You can see that I could say, well, someone might say, okay, what about 4 and 6? 4 people were on the top of the bus, 6 people were sitting on the bottom. Could this be a way that the people sat on the bus? We kind of want the kids to understand, does it make 10? Yes, it does. And so we're able to kind of say, yay, and we can move on. Or we can add it down here with our pen tool. And so we can say, okay, I know that Sally told me that 4 and 6 are going to give me 10. And then you ask another student and you say, okay, can someone else give me another example? And so you see, oh, well, someone says, I just did the 5 and 5. Absolutely, that works too. And so you're kind of giving them context, but also showing the different ways to make 10. And then you are writing the abstract, the algorithm that goes with it, because it's important for our CRA model. If you've never aren't familiar with it, the concrete, representational, and abstract. to kind of be sure that you're kind of looping them all in at the same time. So even though the students aren't writing this in this particular instance, you are. And so you're giving them the kind of context that they need to kind of show all three. So again, this little bus was created just by using our shapes tool here. You also have your text feature here that you can use, and you can say, make 10. Just as an example, you can see that the settings pop up here. I'm going to make this bold. I can make this bigger and change the color. And so you kind of have an idea there. I can move this, copy it, layer it, and there you go. So that's kind of like with the shapes feature that you have. And then if I even wanted to take it a step further, now I'm dealing with kindergarten here, so I'm going to use the number path and not the number line. I'm going to show this number path. I'm going to connect it to my rec and I'm going to show them here's where 1, 2, 3, 4, 5. And then if I move them all over, I can see that 10. I can maybe even put this number path on top so that they can see the connection there. They can see that 5 and 5 make 10. What else can make 10? So that's just kind of an example of some different tools that you can use as well while you're using the rec and rec. You can use all these tools are available with every manipulative that you open. So like I said, it's just a good sense of number 10. It's critical for when you're building these children's reasoning strategies. Once they get a really good sense of the reasoning and making 10, and there's so many different ways you can make 10, not with just the rec and rec, but really any manipulative. We have the 10 frame as well that you can play with and model. So we also want to think about multiple representations and what's going to stick for that particular student and make sense for that particular student. So I could model the 5 and 5, or let's just say the 4 and 6 one. I could model this using my pen tool. I'm going to make my pen really thick just so I can make a very quick circle here. 1, 2, 3, and 4. And then I'm going to use black for the white beads just so they show up a little bit better. And so kids are able to kind of, again, see multiple representations of this same concept. So when we get into first grade, we begin with their learning their basic addition facts. So we want to apply this knowledge, this make 10, to help us with their regular facts. So if we have 8 plus 4 or 9 plus 5, how can we use this strategy to help students extend their learning and go from a basic make 10 to make a 10 strategy? When using a share code, can I see the students' work? So when you make the share code and you give it to your students, it's kind of like passing out someone each one, right? It's going to pass out that individual task to each student. The way that they could share it back with you, so if you wanted to see their work, you could have them create their own share code or copy the image and send it to you like on a Google slide or through Seesaw or wherever your learning management system has they can download the image and upload it. They can copy this image or they can create a share code back to you so that you're able to kind of see. Good question. We also have a live version. We're not going to get into too much of live today, but it is a way that you're able to kind of see all of your students' work at that same time. So a make 10 strategy is when you turn this one number into 10 using compensation to add or subtract that value from the number in the problem. And I got this. There's some number strings that really are helpful. And so I kind of used some number strings that I found. I used the double-decker bus idea to extend my thinking, or maybe you start with this. Maybe the students don't have a great grasp on making 10 when they're in your classroom. So your first grade teacher, you can start with this. This one kind of goes to show that you can show all 1, 2, 3, 4 different ways to make 10. And so if I'm, zoomed in here, I'm going to scroll over so you can see just one at a time. I have them all on the screen, but like I said, you can scroll in and make sure that you're just looking at this first one. So there were some people sitting on a double decker bus. There were 5 sitting on the top and 5 sitting on the bottom. How many people were in all? And you noticed I started with something that the students are probably going to grasp onto and know. We know 5 and 5 is a little bit of a easier one to kind of grasp too. Then we go into the second one here. So sorry, I'm trying to get to it. So the second one, I'm going to move this up a little. And so there were 5 people on the top and there were 6 on the bottom. And so here we're saying, okay, now this is going above our basic just 10. So what can we do? We can see that there's 10 and 1 more. And how I can fill this in is I have 5 here and 6 here. I can move these dots to make 5 and 5 is 10 and have the 1 more left over. When I explain this to my kids, what I just did here was I said 5. Ooh, I'm going to make this a little bit bigger so you can see it a little bit better. So that I have the 5, excuse my handwriting, plus 6. And what I did was I decomposed this 6 into a 5 and a 1 because I know that 5 and 5 are able to make 10. So you're kind of guiding them and showing them ways that they can make 10 using what they already know about decomposition and decomposing numbers. Same thing over here. I move then, so this is, like I said, kind of like a number string setup. Now I have, there were 9 on top and 5 on bottom. So what would I do? 9 plus 5. I can decompose my 5 into a 1 and a 4 because I know that 9 and 1 make 10. And to show that not only here, I can say, okay, so I'm going to bring back 1 here and then add 1 to the top. I can see now very quickly that I have 14 because I see that here's my 10 and then I have 4 more on the bottom. But I can also show this here by just grabbing and moving this dot over. So now I've made the 10. So that's kind of the flow that you want to go through and the differences that you want to go to. So, and then again, you can show this with 9 and 3, and you're kind of working a lot with 9 at first. And so I kind of wanted to show you when you're thinking about that, you go through this 9. So here I am again in Brainingcamp. I've created this share code. When you create a share code, so I'm going to just say, this is what I've set up. I've taken my time. All you have to do is press share and share code. And then you get to copy this code. Now, we don't save these internally, so you are going to want to save them on something that you have created, like a Google Sheet. You can put your standard, you can put a photo of it or a picture of it to remind you of what it looks like, and then the share code, and you can share this with your friends. So we're going to adding 9, but we're going to do it by making a 10. So this is just kind of to give you an example here. We have 9 plus 5. I can see that I have 10 plus what is going to give me 14. So it's kind of almost kind of saying to the kids, this is the strategy we're using this time. We're really going to practice it. So here I can see I can have 9 plus 7. And if I bring this over, I can now see I have 16 as my answer. So 10 plus what? What did I do to this 7? Well, I broke it into a 1 and a 6. The 7 into a 1 and a 6. And so I'm going to say 7 plus, or 10 plus 6, because we know that that's easier to add. And this is with our 2 color counters. So how I got the different colors, again, I used the colors down here in my settings bar right here, and I can change the colors to whatever color works for me, whatever colors I have in my classroom for my color counters. So we really try to match the physical with the virtual so that you can use them in conjecture with each other. So this is adding 9 by making 10. And so again, it's not you're making a 10 within, you're using the making a 10 strategy to kind of help you with your addition facts. Then we move on to second grade, and we start working with two-digit addition. And students are expected to add and subtract within 100 using strategy based on place value, property of operations. And now we're kind of going 37 and 25. Well, often we think of that as a regrouping problem, but we want them to first see, can I make a 10 easy with those numbers? And in my mind, I know that 7 and 3 make 10. So I need to take 3 from the 25 and add it to the 37. So to give you an idea, I'm going to go to our number line application. Your number lines are here. You are able to move them. You are able to copy them. In order just to kind of give you an idea, you can change the range in which you are working with here. So I wanted to give you that option and kind of show you that that is available to use. When you pull out a jump, it will match. In order to change the jump, you click on this number, and then you can change it to 5. So if I wanted to show that 5 and 5 is 10, I could do so here. I could copy this and say, have my students just generally tell me what's another way to make 10. And I could copy this here. Nope, doesn't want to let me do that. So I could say, well, let's do 7 and 3. Again, you can see that they're taking up that same amount. Yes, there are negative numbers. So if I click here, and I'm going to make a copy just to show you, if I drag it this way, you can see the negative numbers are, and if I only want to work with negative numbers, I would bring this here, and then I can move. So you have both negative and positive available. Good question. But I kind of wanted to show you the open number line here, and I'm going to enter this share code here. So now you have two-digit addition to make 10. Again, we're thinking of the idea of how can we use what we already know about making 10 and still use it in the upper grade levels. Right now we're getting into a second grade. We have 52 plus 28. I know that if I add 8, if I take away this 8 and this 2, I know that I can get to 60 very easily, and then I only have to add 20. So that kind of gives you an idea of how really important this making 10 can be. Before we get with the standard algorithm, before we start introducing all these things, we want our students to understand what's happening with this strategy. And like I said, it's just such an important one. And I know I'm stressing it a lot and going over how important it is, but it really is truly something that you and your students can do. Subtraction is the inverse, right, of this, or the opposite of this action is of addition. And both operations involve this like part whole structure. So with addition, the parts are known, but not the total. With subtraction, the total is the one that we don't know. Because we do so much with addition, think addition strategy is probably one of the most powerful tools we can use when we are thinking of subtraction. So using this number line again, I'm going to show you kind of a think addition strategy. So two very important strategies are the make 10 and the think addition. Again, I'm going to show you the share code. I'm entering it here. I'm pressing go, and now I have think addition. What I wanted you to kind of realize is that I started with a number path again here, because this is a basic addition subtraction. K and 1 really should be focusing on a number path, which we have available for you there. And I pulled that right here from my tools. Then I'm able to change just to a regular number line. And then here I'm getting into a little bit more. I've even started my number line at 20, because my think addition, if I have 78 minus 24, I'm going to start at 24, and I'm going to see what I need to do to get me to 78, right? So I could start just by adding tens. Still not there, still not there, still not there. Okay, so I'm getting closer. If I add 10 more, it's going to be too much. So here's where you can start. So I have 10, 20, 30, 40, 50, and I'm going to need 4 more to get me to 78. And you can use this marker if it's a little bit hard to see. You can use the marker and you can see that it shows up there as well. So I know then that 24 plus 54, ooh, maybe too thick, is going to give me 78. Therefore, I thought addition, now I know that 78 minus 24 is going to give me 54. So just to kind of give you an idea of how these all kind of fit together and use, again, these addition strategies are super important for Make 10 and Think Addition. And I kind of focused on just those three, something that we don't focus on a whole lot. Absolutely, there are fractions on the number line. I'll show you that really quick before I move this over to Mark. You do have fractions here. Again, I can change the range that I'm working with, but also the denominators that I'm working with, and this will adjust based on the one you have out there. Good question, and I'm so glad you asked that. Again, check out these workspaces, but also check out the settings because those things change as well with every one that you're using. So I'm going to pass it over to Mark, and he's going to get started on all of his wonderful things that he's going to show you.
All right. Thanks, Kara. That was awesome. That was awesome. Let me switch gears here. Hopefully you can see my screen. And as promised, so we're going to take a little bit of a look at some multiplication and division patterns and how we can, I'm going to say, visualize and get to the concepts and help kids understand the patterns and do it in a visual way. So I am going to start with first, I'm going to start with place value disks. Just a little bit of introduction to place value disks. With my sense is that folks might not be all that familiar with them. Could be an incorrect assumption. I've been wrong before. So I just wanted to spend a little bit of time, a little bit of an introduction to place value chips or place value disks. Now, many of you are probably familiar with base 10 blocks, which are a proportional model or representation of our base 10 number system. Place value disks are also a representation of our base 10 number system, but they're not proportional, right? I'm going to understate it. It's like they're simply disks with numbers that they represent. So since they're not proportional, their size doesn't change, right? So I'm going to take this 1,000 chip out there. But one of the things that we can do with the digital version, I can click on here and I can see I've got some options. I can break that 1,000 into 10/100s, right? So it's still based on our place value system. It's just not proportional, right? So you really want to make, before you introduce these to kids and are using these with kids, you really want to make sure that they have a good understanding of our place value system and how it works and the relationship between. So, I would say after they have a good understanding of place value is a good time to start using place value disks. Quickly, a quick little tour here. So you see there's different number sets, right? Here's whole numbers. I can also use decimals. Notice how my toolkit is changing here. I can also turn on labels for my workspace, right? So if I bring this out here, I can see the value of what I have on my workspace. I'm going to turn that off for now. And then depending on the number system that I've chosen, for whole numbers, I can choose my max. Right now I'm all the way to 1,000,000, but if I just wanted to go to 1,000, I could have that there. But if I now switch to decimals, now it's no longer my max, but it's my minimum value. So I can go to hundreds or tenths. All right. And if I'm in decimals, there's also other workspaces that Kara told us about earlier, right? Those are there's no way we could show you all the little nuggets that you're going to discover with your free license, but take some time to check out the different workspaces. And as Kara pointed out, these tools up here in this toolkit are standard for all our virtual manipulatives. All right, so now that we know a little bit about place value chips, let's take a look at um, multiplication. Let's see, what did I have here? Dividing by multiples of 10, a fourth grade standard. And I've created a share code, and these share codes are in that document that we shared. All right, so I'm going to place it in there. I'm going to click go, and this is something that I've created for you. So we're going to take a look at how you can discover patterns dividing multiples of 10, 100, or 1,000, right? So I just want to switch gears just for a second. Kara mentioned the share codes, that we don't save them quickly. And she recommended that you save them in some type of spreadsheet or Google Sheets so that you can have them for later use. They are not specific to your account. So if you and your colleagues want to take different domains or different topics, and one person creates something about decimals or fractions, and somebody else wants to create something or share codes with early numeracy, you can do those, and you can share them as well. So, good question, Kim. So share codes have an expiration date, or are they out there forever? Share codes are good for as long as you have a valid Brainingcamp license. Thank you, Kara. So as long as you have a license, you can use all the share codes that you have access to. All right, let's go back to dividing by multiples of 10. And we're going to take a look at this strategy that's based on place value as well as based on basic facts. So what I did here is I used this cover tool. I click in this little eye, and how can I think of 9 divided by 3? Well, how can I think of 9? Right? I can think of 9 as 9 ones, right? So I can pull out 9 ones here, and you'll notice I just quick added, and then I'm going to copy, and there's no reason for my having a nice array other than that's just kind of the way my brain works. But at this time, it just kind of helps because now what does 9 divided by 3 look like? Well, I'm going to use fair share, right? So there's one group, here's another group, right? How many are in each group? Go down here. I'm going to pick a thicker, 6 seems to be a good one. 9 divided by 3, how many groups do I have? I have 3 groups. All right, let's take it one more step and let's look at 90 divided by 3. Again, we're looking for that pattern that's going to exist here. How can I think of 90 in this case? And I think this right here probably is giving it away, right? I can think of it as 9 tens divided by 3. Well, here's my 9 tens. I've already built those, right? So now if I'm going to do a little bit of a fair share and think about what division means. All right, so now how many are in each group? What's the value of each of those groups? There's 3 tens in each group, or 30. And again, I can start to look for those patterns. Again, 900 divided by 3. How can I think of 900? Well, it's a giveaway right here, right? But I can think of that as 900s divided by 3. And again, we get into that fair sharing, what division means, right? By 5th grade, they're already used to, 4th grade, they're used to that fair sharing idea of division or concept of division. So what do we have? What's the value of each group? I'm going to use green just because it'll match. And so now I have 300, right? And so now at this time, you could probably start to see that there is some type of pattern going on here with this division. And when we're dividing, we're looking for those patterns when we're dividing multiples of 10. So 9, 90, 900, and so on. So we can discover that pattern using the place value disks to help us understand what's happening here. I like it just because it's more than just giving it to kids in the abstract, right? Rather than just saying, hey, 900s. I can give them an idea of what the 900s looks like using the place value disks. All right, now let's take a look at dividing decimals, moving up to 5th grade. And I'm going to use place value chips again. So I've got my share code. Put that share code in here. All right, and this time I'm using the same type of strategy, right? Strategy placed or based on place value. And so really now the question that I have is how can 45 divided by 3 help me find 4 and 5/10 divided by 3? Well, again, coming back to that fair share, I can put a 10 here, I can put a 10 there. Well, now this has a value of 10. I'm going to bring it over here just so it doesn't get in the way. I'm going to have to break that up, right? And now I can continue to fair share all of these here. Go by that definition of what we know division means. And you're going to get the general idea. I come over to this stack over here. Well, that's not really a stack, that group. And then I can see that my quotient is 15. Make it in blue again. So now how does that work with 4.5? Or I should be accurate and not say 4.5. Oh, thank you, Kara, for putting that in the chat. Shouldn't say 4.5. I should say 4 and 5/10. So it's the same type of approach that we're used to. Kids are used to that fair share. So I'm in my mind, I'm accessing that prior knowledge about what division means to help them discover that pattern, and using 45 divided by 3 to help me find 4 and 5/10 divided by 3. You might even go and look at 4500ths divided by 3. If you want to look for even a deeper pattern, right? We probably wouldn't just say that 2 repetitions is a pattern, right? We may want to check a third, right? So we could build 4500ths and then go through that same type of process. What I did here to get these little, I'll call them buckets, I just used the rectangle tool and just made them large enough so I knew that I could get those discs in there. And I group select, I can lock them so they won't move when I put the chips in there. All right, so that is place value discs in discovering some patterns for division. And let's see, so now I'm going to go, we've got one more for multiplication division patterns, and I'm going to copy that. I'm going to put it in the chat this time so that Kara doesn't have to. There we go, and let's see here. All right. Oh, this one is multiplying. How can we use patterns to multiply by powers of 10? Again, if we have those kids that need to see this, they need to visualize what this means. Well, 8 times 1 can be seen or can be thought of as 8 ones. I'm just going to put one there, and then, you know what? I'm going to do it this way, and I'll copy those. So how might I write that now in my place value chart? Well, make it a little thicker. I've got 8 ones. Pardon my my poor penmanship. All right, 8 times 10. How can I think of that when using what I know about place value? Well, that is 8 tens. Now, you might be saying, well, that's not an array. I'm just organizing them so I'm not building an array. I'm just thinking, all right, what does 8 times 10, what 8 times 10 mean? It means, well, I have 8 tens. So how can I represent that in the place value chart? Again, boy, that's a bad looking, it's a bad looking 8. And then I can continue this pattern for other multiplication of powers of 10, right? 8 times 100. You can think of that as 800s. There's that place value where that comes in. Or 8,000. Again, we don't have to stop there. We could make it 10,000s as well. So a couple of things in using place value chips and discovering that, we'll say this is those patterns in the zeros, right? I'm not going to build it, but I know that this would be 800, right? And it's important that we talk about the decimal point isn't moving. That's why I use the same place value chart, but the digits are moving. And this is in the place value workspace in our in the place value chips application. All right. Now let's go to some integer addition. Boy, I think I may have told Kara the story or somebody the story about years ago where I tried to do some integer work with my students. I taught 8th grade math for many, many years with integers, and it was a total flop. I tried to make a video to show direction and multiplication, and it was just, it didn't work. So I wish I would have had these kind of tools, these kind of digital tools when I was in the classroom many years ago. So let's take a look at integer addition using a number line. I specifically chose a number line because I have a feeling that many of us have probably seen integer chips used for integer addition. And I wanted to take a new approach, and I also wanted to tie it into what Kara told us earlier about the think addition strategy. All right, so what I'm going to do, let's take a look at this first. 12 plus negative 10. I'm purposely going to take this, I'm going to call it a vector, or this arrow, and place it in here to locate positive 12. And there's a reason why I'm going to do that. So now to that, where that arrow ends up, and I'm purposely not going to place a marker there. And now to that, I'm going to add negative 10. So I'm going to place that above there at negative 10. And then I'm going to bring out just a couple of straight lines. Notice when I rotate this around, it snaps, so I know it's at 90. Okay. So if I think about, let me move this one. If I think about that 12, what does that 12 represent? Or that length 12? Well, it's showing me how far 12 is from 0, right? So it is the absolute value, right? Think about the absolute value is how far a number is from 0. And then this, I add a negative 10, right? These arrows represent that absolute value of those add-ins. And so what do I have here? If I think about that comparison model that we probably saw in elementary school, in elementary grades, that's the difference. That's the difference of their absolute values. So I purposely did that because I wanted us to think about how we could connect that to that algorithm, right? We always tell kids, well, just take their absolute values, whichever one has a greater absolute value, the sign of um, the result has the sign of the number with the greater absolute value. So I did that purposely as a way to help see that notion or that idea. Let's go down here. -10 plus -4. Well, this one's pretty straightforward. I'm just adding on to that other arrow. Whoops, operator there. You know what? I'm going to start over. Now I can make this. You know what? I'm going to change the value this way. Easy for me. All right. Well, okay. Operator error, but that happens sometimes. So here we go. Let's get the -10 out there. And now let's get the -4. Well, I'm not going to worry about it now because either my mouse isn't working correctly or there's some operator error. But there we go. There's where we'll end up. And all right, let's take a look at this last one. And -13 again. Here's -13. Let's take a look at that. Okay, I'm really having some issues here, aren't I? Anyway, well, I don't want to waste everybody's time. There we go, -13. And then I could add a +6. I'll use the bars since I was using them before to be consistent. And where do I land? Okay, so again, now coming back here, right? Think of the difference of their absolute values, that comparison model in between there. All right. Sorry for the uh, operator error, but now now I want to come back to using the think addition strategy that Kara shared with us. Another share code. Again, this is in the document that we created for you. How to model integer subtraction and number line using the think addition strategy. Well, the think addition strategy, if we think about those parts of a subtraction problem, right? We've got, and I'm not going to write this all out. We've got the minuend, right? And we've got the subtrahend. Right? So within that, the think addition strategy, it's how do I get from the subtrahend to, in this case, how do I get from there to 10? Well, I can take my vector or my arrow, and now I get that this is +8. That was pretty straightforward, right? Because it's a subtraction of whole numbers. Neither one, I mean, they are integers, but neither one's less than 0. Or this minuend is greater than the subtrahend. But what about we had something like 2 minus 10? Again, think addition strategy says, how do I get from the subtrahend to the minuend? Well, in this case, now I'm going to go, well, now it's working really well for me. So there is my difference of -8. And let's take a look at one last example. 2 minus negative 10. Again, think addition. Negative 10. How do I get to positive 2? So again, that's the think addition strategy. I'm thinking, how do I get from the subtrahend to the minuend? Now, I'm not saying that kids need to understand or know those terms, right? But that's how I'm thinking about it. That's what's working for me to help myself make sense of the think addition strategy. All right. Well, we are almost out of time, and I didn't see any lingering questions on integers or multiplication division patterns. So I'm going to go back to our PowerPoint and kind of want to wrap it up. So thank everybody for their time tonight. Get in there, access those things on those resources on the Google Drive. I did have 2 slides. I wanted to put this on the same slide to see the power of that think addition strategy, how it's applicable in elementary, as well as when we get to middle level grades and start working with integers, right? Same strategy. I don't know if you joined us last month, we talked about the area model and how that was the same strategy and same model used throughout. Really accessing kids' prior knowledge on what they know and building on that for those new concepts, helping them make those connections. We do have on the screen, you'll see our contact information. Feel free to email Kara or myself if you have questions, or if you have questions, you're not sure how you might want to do something. We're both former teachers. We both want to help and make sure that our resources are being used. There's other contact information there for general support emails, general info, if you're interested in sales. If we do have a partnership program, so if you're with a content provider and you're interested in partnering with Brainingcamp, you can email us at partners@brainingcamp.com.